Good morning, students. So far, we have learned about polynomials, polynomial fractions, proper, improper fractions, reducible, irreducible polynomial, and the methods to resolve the given fraction, given proper fraction into sum of partial proper fractions, etc. So the previous class, we have learned the different methods to resolve the given proper fraction, especially into the sum of partial proper fractions. So what if the given fraction is an improper fraction is what we are going to discuss in this session. So first of all, what is meant by proper fraction? Proper fraction is a fraction where the degree of a numerator is less than that of denominator. On the other way around, proper fraction is nothing but in a fraction the degree of numerator is greater than that of the denominator. So such fraction is said to be an improper fraction. So improper fraction if f of x by g of x is a given fraction, if degree of f of x is greater than that of degree of g of x, then that kind of a fraction is said to be improper fraction. So far we have learned the methods to resolve the given proper fraction into sum of partial proper fraction, and this process is nothing but finding the resolving into the partial fractions. Now, how do we resolve the given improper fraction into proper fraction, and then how to resolve it through the process of partial fraction is what we are going to learn now. Here two cases arise. One is degree of f of x is greater than degree of g of x, and the second one is degree of f of x is equals to degree of g of x. For improper fraction, the concept of division algorithm is used. So what does the division algorithm say? So if f of x and g of x are two polynomials, then there exists the two polynomials q of x and r of x such that f of x is equals to q of x plus into g of x plus r of x, where q of x is the quotient polynomial and r of x is the remainder polynomial. So where this remainder could be 0, where r of x could be 0, or degree of r of x is less than degree of g of x. So this is the division algorithm. So if there is a improper fraction given, then to convert that improper fraction into a proper fraction, the concept of division algorithm will be used. So according to this, f of x is equals to q of x into g of x plus r of x. So if we divide with g of x on both the sides, Then this is q of x into g of x by g of x is q of x plus r of x by g of x. So where q of x is a non-zero polynomial and r of x by g of x can be resolved through the process of partial fractions, because this is going to be the proper fraction, and we know how to deal with the proper fraction. So we have altogether 4 methods. So type 1, type 2, type 3, type 4. Type 1 and type 2 are dealing about denominator contains linear factor. So type 1 non-repeated linear factor, type 2 repeated linear factor. Type 3 and type 4, the denominator contains non-repeated irreducible quadratic factor and repeated irreducible quadratic factor. So with the help of these 4 methods, we can solve this particular case. So let us emulate with an example of how to resolve this improper fraction into the partial fractions. So let us take x cube by x minus 1 into x minus 2. So first of all, this is a polynomial in x and this is a polynomial in x, or rational fraction, or simply a fraction. Now degree of f of x is 3 and degree of denominator is x into x square 2. So this 3 is greater than 2. So degree of f of x is greater than degree of g of x. So how do we solve? So let us divide this x cube with this denominator x minus 1 into x minus 2. This is x square minus 3x plus 2. If you multiply this, we'll get this. So x cube by x square is x. So x into x square is x cube. X into minus 3x square. X into 2 is 2x by. So this is minus plus minus gets cancelled, 3x square minus 2x. Now further division is possible or not is depending upon this. So here the degree of r of x remainder is 2 and here degree of g of x is also 2. So as long as degree of r of x is less than degree of g of x, we will continue. So until the degree of remainder is less than degree of the g of x, we will continue the process. Therefore here, since the degree of both remainder and g of x are equal, therefore further division is possible. So let us divide. 3x square by x square is 3. With 3 will multiply. 3 into x square, 3x square. 3 into minus 3x minus 9x. 3 2s are 6. So this is minus plus minus. So 9x minus 2x is 7x minus 6. Now the degree of r of x remainder is 1 and the degree of g of x is 2. Degree of remainder is less than degree of g of x. Therefore, this x cube is equals to q of x is x plus 3 into g of x square minus 3x plus 2 plus the remainder is 7x minus 6. So x cube is equals to this into this plus this. So if we divide with x square minus 3x plus 2 on both the sides, x square minus 3x plus 2. So this is x plus 3 into x square minus 3x plus 2 by this is x plus 3 plus this is 7x minus 6 by x square minus 3x plus 2 is x minus 1 into x minus 2. So we got x plus 3b to be the polynomial, and this is 7x minus 6 by x minus 1 into x minus 2. This is a proper fraction because the degree of a numerator is 1 and the degree of the denominator is 2. Degree of f of x is less than degree of g of x. Therefore, this is proper fraction, and we know the method to resolve this proper fraction into sum of partial fractions. So type 1 can be used here. So this is a by x minus 1 plus b by x minus 2, and a comma b ought to be evaluated. So this is the first case. Degree of f of x is greater than degree of g of x. And the next one is degree of f of x is equals to degree of g of x. So how do we do this? So degree of f of x is equals to degree of g of x. So f of x is equals to k into g of x plus r of x we will get. K into g of x plus r of x. So according to the division algorithm, so k into g of x plus r of x. What is this k? K is a constant. Here k is a constant which is the coefficient of the highest degree terms of f of x and the coefficient of highest degree terms of g of x. So this k is the constant, so which will be discussed through the illustration of one example. So here f of x is equals to, so divide with g of x on both the sides. This is k plus r of x by g of x. So where k is the constant, that is a coefficient of the highest degree terms of f of x and the coefficient of highest degree terms of g of x. To discuss this, let us emulate with an example. X square by x minus 1 into x minus 2. So here the degree of f of x is 2 and the degree of g of x is also 2, x into x square. So divide the numerator f of x with the help of denominator, which is x square minus 3x plus 2. So x square by x square is 1. So 1 into x square, 1 into minus 3x is minus 3x, 1 into 2 is 2. So minus plus minus. So 3x minus 2. So here the degree of the remainder is 1 and the degree of the divisor is 2. So therefore degree of r of x is less than degree of g of x. Therefore the division process will be ended with this. Now this x square is equals to x, according to the division algorithm, f of x is equals to g of x into q of x. So x square minus 3x plus 2 into 1 plus 3x minus 2. So to get this, I'll divide with the x minus 1 into x minus 2 on both the sides, x minus 1 into x minus 2. So this is equals to x square minus 3x plus 2 is x minus 1 into x minus 2 into this one is this by x minus 1 into x minus 2 plus this is 3x minus 2 by x minus 1 into x minus 2. So this gets cancelled. We get k plus r of x by g of x. So where k is nothing but this k is nothing but the coefficient of the highest degree term in the numerator. X square quotient is 1 here. Fine. The x square quotient here x square minus 3x plus 2. So the quotient of the highest degree term is x square quotient is 1. So 1 by 1 is 1. So this one is this. K value is 1. So 1 plus what is r of x? 3x minus 2 by x minus 1 into x minus 2. And we know how to deal with this. This is a proper fraction. This is a proper fraction because the degree of numerator is x power 1 here. Here x into x square. So degree is 2 here. So the denominator contains two non-repeated linear factors. For every non-repeated linear factor, there exists a partial fraction of the form a by ax plus b. So this is a by x minus 1 plus b by x minus 2. A and b are to be evaluated. This is how we will solve the partial fraction for improper fraction. Resolve the following fractions into partial fraction. Exercise 7C, first problem. So the example which we have taken for the illustration is what we have got here. So here this is a fraction. Which kind of fraction? Both are polynomials in x. Which kind of a fraction? Degree of numerator is 2 while degree of denominator is also 2. So degree of f of x is equals to degree of g of x. So how do we solve this? This is equals to the coefficient of x square in the numerator is 1 by the coefficient of x square, because if you multiply this x square minus 3x plus 2 is x square quotient is here 1. This is our k plus. How do we solve this partial fractions? So x minus 1 is a non-repeated linear factor. X minus 2 is also a non-repeated linear factor. So a by x minus 1 plus b by x minus 2. So this is equals to 1 plus a by x minus 1 plus b by x minus 2. Where this one we got by taking the coefficient of highest degree term in f of x by the coefficient of highest degree term in the denominator. So this is equals to LCM here in x minus 1 into x minus 2 by 1 is x minus 1 into x minus 2 only. So this is x minus 1 into x minus 2 plus x minus 1 into x minus 2 by x minus 1. So this gets cancelled. A into x minus 2 plus x minus 1 into x minus 2 by x minus 2. X minus 2 gets cancelled. B into x minus 1. So this is equals to x square by x minus 1 into x minus 2. These two gets cancelled. So we are left with x square is equals to x minus 1 into x minus 2 plus a into x minus 2 plus b into x minus 1. So x minus 1 is a linear factor equated to 0, x equals to 1. and here x equals to 2. These are the two values we are going to substitute for x in this equation. Put x equals to 1, 1 square is equals to, here 1 minus 1 0, 0 into this is 0. So here also 1 minus 1 is 0. So we are left with a only, a into x minus 2, 1 minus 2 is minus 1. So therefore a is equals to minus 1. Put x is equals to 2. 2 square 4 is equals to 2 minus 2 is 0 into this is 0. 2 minus 2 is 0. So b into 2 minus 1 is 1. So from this b is equals to x square by x minus 1 into x minus 2 is equals to 1 plus the value of a is minus 1. So this is minus 1 by x minus 1 plus b value is 4 by x minus 2. Now this is again an improper fraction. Degree of numerator is 3 and degree of denominator is x into x square 2. So 3 is greater than 2. So here we need to divide this x cube with the help of this. So x cube. Otherwise if it is x square by x minus 1 into x plus 2, we need to divide in that situation also. But without actually dividing it, we have simply the coefficient of the highest degree term in f of x by the coefficient of the highest degree term in the denominator plus usual partial fractions we will take. So there also division process we will take, and later on division algorithm is what we have to use there also. But that was the shortcut. So here we don't have any shortcut here except going in a conventional way, which is a division process. Now this is x into x square, x into 2 2x minus x, so plus x, minus 1 2s are minus 2. So x cube by x square, so x times x into x square x cube, x into x square, x into minus 2 minus 2x, x into x square, x into minus 2 minus 2x. So subtraction. So this is minus x square plus 2x. So further division is possible because the coefficient of remainder should be less than that of a quotient of a divisor. But here degree of both of them are equal. Therefore further division is possible. So minus x square by x square. So minus 1. With minus 1 we have to proceed. Minus 1 into x square minus x square, minus 1 into x minus x, minus into minus plus 2 1s are 2. So subtraction again, plus minus gets cancelled. 2x plus x is 3x minus 2. So therefore x cube is equals to x square plus x minus 2 into x minus 1 plus 3x minus 2. According to the division algorithm, f of x by g of x, there exists the polynomials q of x and r of x such that f of x is equals to q of x into g of x plus r of x. Here q of x into g of x plus r of x. Now given fraction is x cube by x minus 1 into x plus 2. So for that, let us divide with x minus 1 into x plus 2 on both the sides. So this is equals to, this is all a plus b by c, a by c plus b by c. So x square plus x minus 2 is x square plus x minus 2 into x minus 1 by. So this is x minus 1 into x plus 2 plus 3x minus 2 by x minus 1 into x plus 2. These two gets cancelled because x minus 1 into x plus 2 is nothing but x into x square plus 2x minus x is plus x minus 2. So this is equals to x minus 1 plus 3x minus 2 by x minus 1 into x plus 2. So we can put aside this the polynomials x minus 1 since this is not a fraction. But here this is a fraction and this improper fraction becomes a proper fraction here. X power 1 here and x into x square. So degree of f of x is less than degree of g of x. Therefore partial fractions is used to solve this proper fraction. So I will take this separately. So 3x minus 1 by 3x minus 2 by x minus 1 into x plus 2. So this is equals to, the denominator contains two non-repeated linear factors. So type 1. So a by x minus 1 plus b by x plus 2. So this is a into x plus 2 plus b into x minus 1 is equals to 3x minus 2. X equals to 1 and x equals to minus 2 are going to be used for substitution of the value of x. Since x minus 1 is a factor, x equals to 1 is the root. So put x equals to 1. 3 ones are 3, 3 minus 2 is 1. So a into 1 plus 2 is 3. So here this is 0. From this a is equals to 1 by 3. Put x equals to minus 2. 3 into minus 2 is minus 6. Minus 2. So minus 8 is equals to a into minus 2 plus 2 is 0. So b into minus 2 minus 1 minus 3. So minus from both the sides gets cancelled. B is equals to 8 by 3. Therefore, x cubed by x minus 1 into x plus 2 is equals to x minus 1. This is as usual. This 3x minus 2 by x minus 1 into x plus 2 is a by b by. The value of a is 1 by 3. So 1 by 3 by x minus 1. 1 by 3 into x minus 1 plus 8 by 3 by x plus 2. So this is 8 by 3 into x plus 2. X cubed by 2x minus 1 into x minus 1 whole square. Again, this is the improper fraction with the degree of f of x and g of x is equals to 3. Here x cubed. On expansion, this is x square. X square, here 2x. 2x into x square, 2x cube. So, this is equals to the coefficient of the highest degree term on the numerator is x cube, quotient is 1 by the coefficient of highest degree term in the denominator is, this is x square, this is 2x. So 2x cube, x square into 2x, 2x cube. So the quotient of highest degree term in the denominator 2x cube. So x cube quotient is 2 here. plus. So how do we proceed this through the process of partial fractions? 2x minus 1 non-repeated linear factor, x minus 1 a repeated linear factor repeated twice. So a by 2x minus 1 plus b by x minus 1 plus c by x minus 1 whole square. So this is how we have to proceed. So here x cube is equals to 1 by 2 into 1 by 2 into, so 2x minus 1 into x minus 1 whole square plus r of x, where degree of r of x is less than degree of g of x, that is 2x minus 1 into x minus 1 whole square. Its degree is 3 here. So, with compared to this, it will be less than this. So, this is equals to x cube by 2x minus 1 into x minus 1 whole square is equals to 1 by 2 into 2x minus 1 into x minus 1 whole square plus r of x by 2x minus 1 into x minus 1 whole square. So this is equals to 1 by 2, this gets cancelled, plus r of x by 2x minus 1 into x minus 1 whole square. This all is the explanation of this. So if you got this directly, then no issue. So we can proceed from here itself. So this is all the explanation. Okay. Now, x cube by 2x minus 1 into x minus 1 whole square is equals to, so the LCM here is 2 into 2x minus 1 into x minus 1 whole square. So 2 into 2x minus 1 into x minus 1 whole square by 2 gets cancelled. We are left with this 2x minus 1 into x minus 1 whole square plus a into 2 into 2x minus 1 into x minus 1 whole square by 2x minus 1. This gets cancelled. We are left with 2 into a, 2a into this. So 2a into x minus 1 whole square plus b into, so this is 2 into 2x minus 1 into x minus 1 whole square by x minus 1. So x minus 1 gets cancelled. So this into b. So 2b into x minus 1 into x minus 1 into 2x minus 1 plus. So 2 into 2x minus 1 into x minus 1 whole square by x minus 1 whole square. So these two gets cancelled. We are left with this into c. So 2c into 2x minus 1. This is equals to, these two gets cancelled on both the sides. So this implies x cube is equals to 2x minus 1 into x minus 1 whole square plus 2a into x minus 1 whole square plus 2b into x minus 1 into 2x minus 1 plus 2c into 2x minus 1. So here x minus 1 equals to 0, x equals to 1, 2x minus 1 equals to 0, 2x equals to 1, x equals to half. So x equals to half and x equals to 1 are going to be substituted for x. Here 2 into x cube, so 2x cube here. Now put x is equals to half, because 2x minus 1 is the factor, is equals to 0 equate, 2x equals to 1, x equals to half, and x minus 1 is the factor equal to this 0, x equals to 1. So x equals to 1 by 2 and x equals to 1 are going to be substituted for the value of x. So 2 into x cube is 1 by 2 whole cube is 1 by 8 is equals to, I'm substituting this 1 by 2 here, 2 into 1 by 2. So 2 gets cancelled, 1 minus 1 0, this all 0. So this 0, this will be 0. So we are left with only this term. So 2a into x values 1 by 2 minus 1 is minus half whole square. So 1 by 4. So 2 on both the sides gets cancelled. So 4 2s are 8. So a is equals to 1 by 2 we get. Now put x is equals to 1. Substitute here. 2 into 1 cube is 2. So 1 if you substitute here, 1 minus 1 whole square, 0 square into this 0. So 1 minus 1 0. This is also 1 minus 1 0. So we are left with the last term only. So 2c into 2 into 1. 2 minus 1 is 1. So 2 gets cancelled. Therefore, c is equals to 1. Now, we are not left with any root because there are the only two roots of there. Therefore, we have used x equals to half and x equals to 1. So, all that we need to do is the comparing coefficients on both the sides. Comparing coefficients of, you may compare the quotient of x square, x cube, x are constant on both the sides. So, comparing quotients of x square on both sides. So, here we don't have any x square quotient, 0 is equals to. So, this is 2x minus 1 into, this is x square minus 2x plus 1. So 2x into x square, 2x cube, 2x into minus 2x minus 4x square, 2x into 1, 2x. Minus 1 into x square minus x square, minus into minus plus 2x, minus 1. So here minus 4x square minus x square minus 5x square. So here the quotient of x square is minus 5. So here, this is 2a into x square minus 2x plus 1. 2a here. So plus 2a. Here, 2b into x into 2x, 2x square. And remaining all terms will be x and constant. So we can leave it. So x square quotient is 2 2s are 4b. So this is equals to minus 5 if you transpose onto this side plus 5 is equals to 2 into the value of a is 1 by 2 plus 4b. So 2 gets cancelled. This plus 1 if you transpose onto this side. So 5 minus 1 is equals to 4. 4 equals to 4b. From this b is equals to 1. Therefore, x cube by 2x minus 1 into x minus 1 whole square is equals to 1 by 2 plus the value of a is 1 by 2 by 2x minus 1. So 1 by 2 into 2x minus 1. So this is 1 by 2 by 2x minus 1. A by b by c. A by b c. 2 into 2x minus 1 plus b value is equals to 1. So 1 by x minus 1 plus the value of c is 1 by x minus 1 whole square. Fourth question is the last question from the exercise 7c. So here this is clearly a an improper fraction because the degree of both the numerator and denominator is x cube only. So that is 3 only. So degree of f of x equals to degree of g of x. So k plus r of x by g of x. So what is k? K is nothing but quotient of coefficient of highest degree of the numerator, which is f of x, and denominator g of x. So here, what is the quotient of the highest degree here? This is x cube. X cube quotient is 1 by here x minus a into x minus b into x minus c. So x cube and remaining terms we will be getting. Amongst all the terms, x cube is the highest degree. So its quotient is x cube quotient is 1. So 1 plus. Now normally how do we treat this how do we treat this now normally how do we treat this proper fraction? This denominator contains 3 non-repeated linear factors for which we need to take a by x minus a plus b by x minus b plus c by x minus c. So a by x minus a plus b by x minus b plus c by x minus c, because the first type says that if the denominator contains non-repeated linear factor for each non-repeated linear factor of ax plus b, there exists a partial fraction of the kind a by ax plus b. So for that, actually this is a linear factor, non-repeated linear factor of the form ax plus b, 1x plus minus a, ax plus b. So this is how we will take. Now, let us proceed this. So x cube by x minus a into x minus b into x minus c is equals to, this is all x minus a, x minus b, x minus c. So x minus a, x minus b, x minus c by 1 is this itself. X minus a, x minus b, x minus c plus, so a into this and this gets cancelled. So x minus b into x minus c plus b into x minus a into x minus c plus c into x minus a into x minus b. So these two terms on both the sides gets cancelled. We are left with x cube is equals to x minus a, x minus b, x minus c plus a into x minus b, x minus c plus b into x minus a, x minus c plus c into x minus a, x minus b. So x minus a, x minus b, x minus c are the 3 factors. So equate them to 0. X equals to a, x equals to b, x equals to c, or what we are going to get for the values to be substituted for x. So put x is equals to a. So a cube is equals to, on substitution of x equals to a in this, a minus a is 0. 0 into something is 0. So here also a minus a is 0 into this 0. This also 0. So we are left with the A term. So A into x minus b. So A minus b into A minus c. From this, A value is equals to A cube by A minus b into A minus c. So put x equals to b. So we will get b cube is equals to b into b minus a, b minus c, and remaining all terms would be 0. So b minus b is 0. So here b minus b is 0. Here b minus b is 0. So we will left with this term itself. So from this, b is equals to b cube by b minus a into b minus c. Similarly, put x equals to c we get, then we will get a c cube is equals to c into last term c minus a into c minus b. From this, c is equals to small c cube by, this is small c cube, by c minus a into c minus b. Therefore, given improper fraction x cube by x minus a into x minus b into x minus c is equals to 1 plus the value of a is this by x minus a. So a cube by x minus a into a minus b into a minus c plus b cube by x minus b into b minus a into b minus c plus c cube by x minus c into c minus a into c minus b. Thank you for watching.
Yeah, 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 yeah.